Pesticides are substances used especially in agriculture to combat harmful organisms. Among these pesticides, the simplest in structure is iodomethane. It selectively attacks sensitive regions of DNA, RNA, and proteins. It adds a methyl group to these molecules, in other words, it methylates them. Of course, DNA is naturally methylated in the body, and this process is crucial for proper cellular function. However, the body tightly regulates where, when, and how this methylation occurs. Iodomethane, on the other hand, enters cells and causes random and uncontrolled methylation. Iodomethane poses the same risks to humans and other living beings. Because of these hazards, the use of iodomethane as a pesticide is highly controversial and has been heavily restricted or banned in some countries. I, however, need iodomethane in my lab for a completely different purpose. There are various methods for synthesizing iodomethane. I'll obtain it by reacting potassium iodide with dimethyl sulfate. Iodomethane has a very low boiling point, just 43 degrees Celsius. So I have to work very carefully during the synthesis. I add the pre-calculated amount of potassium iodide into the flask. I'll purify the resulting iodomethane by distillating it directly from the reaction mixture. That's why I set up the distillation system from the start. To minimize the loss of volatile liquid, I cool the receiving flask in an ice bath. Another challenge of this reaction is the extreme toxicity of dimethyl sulfate. Especially when inhaled, it can cause delayed but deadly effects. Dimethyl sulfate is also considered a potent carcinogen. Let me share a real-life case involving this compound. The toxic human case, known as the Gloria Ramirez incident. Gloria, a cancer patient, was brought to an emergency room in 1994. Doctors and nurses treating her began experiencing nausea, dizziness, and even fainting. Later investigations found unusual chemical substances in Gloria's blood and body fluids. One intriguing hypothesis suggested that dimethyl sulfone found in Gloria's body might have been converted into dimethyl sulfates under specific conditions. If true, that could explain the poisoning of the medical staff. Now back to the experiment. Dimethyl sulfate is normally colorless, but the liquid I used is brown. Such a contaminated region should be purified by distillation, but I'll take a calculated risk and use it as is. Despite working under a strong fume hood, I'd rather not release additional toxic vapors during a purification step. As long as the reaction proceeds, even a low yield will be sufficient for my needs. I begin heating the reaction mixture. The gas escaping the trap at this stage is unlikely to be iodomethane, since the thermometer is still reading only 25 degrees Celsius. 15 minutes later, boiling begins. The temperature reads 35 degrees Celsius. Atmospheric pressure here is slightly below 1 atmosphere, and the fume hood's airflow reduces pressure even further. So it's completely expected that iodomethane boils at a lower temperature under these conditions. I start collecting the liquid. I obtained iodomethane with a 62% yield, quite close to the theoretical value. A very satisfying result. Iodomethane degrades upon prolonged exposure to light, releasing iodine. To protect it, I'll wrap the storage bottle in an aluminum foil. Since it also has a low boiling point, I'm storing it in the freezer. I'll be working with this compound a lot, so take care, iodomethane, and don't you dare to decompose.